Well, hi everyone. Got a video here on square root functions, which we kind of got introduced to already, but we'll just start over again with it. And then also we're going to get into square root inequalities and what the graphs and such look like. So as we start, I want to start with the parent function. F of x equals the square root of x. If I make a table x and f of x, remember f of x and y are kind of the same thing, then if x is, first of all, if x is negative 1, this is the square root of negative 1, which is I, but we're only on a real number axis here. So this won't work. It doesn't start working until 0. And the square root of 0 is 0. So 0, 0 is a point. 1, and then square root of 1 is 1. 1, 1 is a point. Now, I could do 2, and that's like 1.4, and 3 is like 1.7. 4 is 2. Square root of 4 is 2. Yeah, square root of 5, square root of 6, square root of 7, square root of 8, square root of 9 is 3. These are just some values we know. These rest are decimals that are in between. Let's see. 11, 12, 13, 14, 15, 6. Square root of 16 is 4. So you can see kind of how the curve, it keeps increasing, but not by a bunch, the square root functions. Now, what I'd like for you to see is that 0, 0 and that 1, 1, and maybe even that 4, 2 point there. The domain, how low or how far left will this go? Well, it will go to 0, and then it'll increase to the right forever. Now the range, what's the lowest y value? The lowest y value is 0, and then it will increase. Doesn't seem like very fast, but it will go to infinity as well. And if you remember some of these transformations, h is the left or right shift. And remember, if it's negative, it's right after the minus, we go right. And if it's if it's a plus, we would go left. And then the plus k, that's up. If it's positive, k is positive, or down if k is negative. The a is kind of the compress. If a is, let's say, well, let me say if the absolute value of a, let me ignore the positive or negative, is between 0 and 1, stretch if the absolute value of a is greater than 1. And then, I didn't leave enough room, but flip if a is negative. Or another way of saying is if a is less than 0. Let's just remember those things as we go ahead and graph some of these. Now, you can make tables, that's fine, but if you know this one, this graph is this, but with a shift of 3 units right. If I shift this 3 units to the right, 1, 2, 3, and start here instead of here, then I do the same thing. I go, remember that 1, 1, and that 1, 2, 3, 4, 2, and maybe that 1, 2, 3, 4, 5, 6, 7, 8, 9, 3. So this one kind of looks like this. The domain, the lowest x value is 3, and that's included, so I have that square bracket, to infinity. The range is still 0 to infinity. We didn't shift it anyway. Now, this one we would shift 6 left and and 2 up. Get back in focus here. So I'm going to shift this 1, 2, 3, 4, 5, 6 to the left and 2 up right here is my starting point. And then you remember that 1 over, 1 over. What if I go over 1, 2, 3, 4 and then up 2? I could even go, that's 4, 5, 6, 7, 8, 9. Square root of 9 is 3. So I'll go up 1, 2, 3 units from there. And that is kind of what that looks like. The domain. What's the farthest left we go? Looks like -6 inclusive. And it'll keep going to the right. What's the furthest down that we go? Looks like 2. And it'll keep going up. So there's the domain and range. Alright, well here we got a trickier one. This is f of x equals -2 times the square root of x plus 4. Alright, so what we're going to do is we need to flip over the x-axis. That's what the negative does. And then we're also going to need to compress by 2, but we're going to shift 4 to the left. So let's shift this 4 units to the left. 1, 2, 3, 4, and start here. We don't go up or down with that. So there's our starting point, but we are flipping it. So instead of going up like this, we're going down like this. I think a good way to do this is instead of going, when I go right 1 and over 1, I'm going to go right 1 and 2, except it's negative. So I'm going to go right 1 and down 2 units here. And you know those other ones, that's 1, 1, and that 4, 2. So if I go over 4, instead of 2, I'm going 2 times 2. That's that. We're multiplying that by 2, how much we're going down. But it's negative, so we're going down 4. 1, 2, 3, 4. 1, 2, 3, 4. Right here. So this is a little, instead of not being quite as flat of a curve, this is a little more expanded on the curve. We're stretching it. And if you wanted, we could do 9 and then go 6. 1, that's 4, 5, 6, 7, 8, 9, and down 4, 6 here. So this is kind of what this curve is looking like. A little steeper of a curve than these, but it's also going upside down. And then I'm going to shift this one 5 units to the right and 3 units up. See if that makes sense. 5 units to the right, 3 units up. 1, 2, 3, 4, 5. 1, 2, 3. That's right there. And then I have got to, when I do this, compress it. By 1/4. So when I go 1 over 1, I'm only going to go up 1/4, just a little bit. When I go over 4, I'm going to go up half. 1, 2, 3, 4. Up a half. I don't know if that makes sense to you. I could be putting this in a table. Maybe that would help a little bit. Okay, see, we knew we had to start at 5 and 3. If I go 6, then it's 6 minus 5 is 1. Square root of 1 is 1. 1/4 plus 3, that's 3 1/4. Okay, and then if I go 9, I'm going 9 because that's 4 away from that. 9 minus 5 is 4. Square root of 4 is 2. A fourth of 2 is a half, and a half plus 3, that's 3 and a half. And then, 1, 4, if I go 9, so if I go out 14, I'll get into my table, I think, but that's all right. 14 minus 5 is 9. That's 3/4. 9 minus 5 is 4. Square root of 4 is, 14 minus 5 is 9. Square root of 9 is 3. A fourth of 3 is 3/4. So that's up to 3 3/4. So that's almost 4. So there's 9, 10, 11, 12, 13, 14. Told you I was going to get right into the table here. Right around there. So this is a very narrow. We might do better with graph paper on this. I'll try to make sure I know that. Okay. And then, you see my base here is not plain, is it? All right. Now, graphing a square root inequality. We're going to graph the boundary with a solid or dotted line, and we're going to shade below if less than. We'll shade above if greater than. All right, so my fifth example here are inequalities. What I want to do is just figure out what the boundary would be. And the boundary function, I should say graph the boundary function, but the boundary function is, and I'm just use y here, y equals square root of 2x plus 1. And this one's a little different. I'm going to factor the 2 out. And that's x, the 2 that's in front of the x. And 2x divided by 2 is x. 1 divided by 2 is 1/2. Okay? And then y is equal to the square root of 2. I'm going to split these up like this, to the square root of x plus 1/2. And I think if you do the math, you're going to see that's about 1.4. Clear. The square root of 2. This is a little more involved, and I'm going to go approximate here. About 1.4 times the square root of x plus 1/2. So you can see that our factor here is 1/2. So I'm going to go ahead and graph this. I know I need to shift our square root function, which starts at 0, 0, 1/2 unit to the left. Graph about like this. There's 1 unit. I'm going to use the units here. So 1/2 a unit is right here. This is -1. Shifting it 1/2 a unit to the left. And maybe it'll be easy if I make a table here. If I were to do, okay, if I were to shift, so if x is -1/2, I know that we have 0. This is for the boundary. I'm going to use a solid boundary line on this because of the or equal to part. Now, if I go 1/2 a unit over, I'm taking, if I go 1/2 unit, 2 times 0, I'm taking the square root of 1. So at 1/2, we are at 1. let's see, if I go 3.5 here, then, let's see, okay, I just noticed something here. So at 1/2 it's 1, but I forgot about this 1.4, so that's 1.4. So 1.4 is right around there. And then at 3.5, I have 3.5 plus 1/2 is 4. Let me just write that over here. 1.4 times the square root of 3.5 plus 1/2. And then 3.5 plus 1/2 is 4. And that makes 2 times 1.4, which is 2.8. So at 3.5, this is 1, this is 2, this is 3, this is 4. 3.5 is around 2.8, which is right around here. So this is a solid boundary line, I just remembered. This is greater than, and we go up. We do not go over here. Our graph doesn't go that far to the left, our boundary line. So we go above, and we're shading, because it's an inequality. Inequalities mean shade. These mean shade. All right. Now, let's look at this one. All right. The boundary for this one, we're going to graph the boundary, is y equals negative square root of x plus 2 minus 4. This will be probably a little easier to graph than that one was, because all we got to do is shift the parent function left 2 and down 4. Okay, so I want to kind of make this like this. So I'm going to go left 2, 1, 2, down 1, 2, 3, 4, and put that point there. And I'm going to use dotted. I got to remember that. And you remember, if we go 1 over and we go 1 up, there is no compression, except I got to flip it. Forgot I got to flip. So I'm going to go down 1 instead of up 1. And if I go over from here, 1, 2, 3, 4, I'm going to go down 1, 2. So here. All right, so just kind of shift that over a little bit to line up with that a little better. And then dotted. Good thing I'm using a pencil today, huh? Dotted the way this curve goes. And it is less than. So I just keep looking down here. Less than is below. So I'm going to shade below our boundary here. That's the ordered pairs that would fit are in this shaded area. This ordered pair right here. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, negative 10 is in this shaded area. There's all sorts of anything over here is in the shaded. I just pointed out this one, 2, negative 10 would be true here. All right, that's what I have for you here.